Algebra 1 students, welcome to your video on completing the square. The big idea is that any quadratic equation can be solved by creating a perfect square trinomial on one side. All right, and so that's some of our examples. So it says to find the value for C that creates a perfect square trinomial. So in this case, it's just asking you, what will C be equal to? Well, we're going to take B, we're going to cut it in half, and then we're going to square it. So C would be 3 squared, which would be equal to 9. All right. Again, we're going to take half of B, and then we're going to square it. So C would be equal to 11 squared, or 121. All right. We're going to take half of B. C is going to be equal to half of B, and then we're going to square it. So this would be 9 fourths. Okay. Next, it says solve by completing the square, round to the nearest hundredth if necessary. I'm going to cross this part off. I'm going to say, leave your answer in exact form. Okay, so I'm going to take half of B and I'm going to square it. I'm going to add that to each side. So half of 16 would be 8. So I'm going to rewrite this. X squared plus 16x plus, I want to put my square in there, 17 plus whatever my square is. Let's change colors here. Okay, 16 divided by 2 is 8. And I'm going to add 8 squared to both sides. 8 squared is 64, so I'm really adding 64 on both sides. Then I'm going to factor this left-hand side. When I do that, I end up with x plus 8, quantity squared, is equal to 81. Then I'm going to take the square root of both sides. When I take the square root of both sides, I'm going to end up with plus or minus the square root of 81 over here. I'm going to end up with x plus 8 over there. That takes care of both of those sides of the equation. So I can actually do the square root of 81. I should have done that. That's 9. Okay. I'm going to subtract 8 on each side using the subtraction property of equality. And x is going to be equal to negative 8 plus or minus 9. Or x is going to be equal to 8 minus 9, which would be 17. Actually a negative 17, sorry about that. And then negative 8 plus 9, which would be a positive 1. So x is equal to negative 17 and positive 1. All right. On this one, I've got x squared minus 2x plus, I'm going to add something into my equation to complete the square. Okay? It's going to be half of b quantity squared, so it's going to be 1 squared. If I add something to one side of the equation, I've got to add it to the other side of the equation. So 1 squared is equal to 1. Okay? So 24 plus 1 is 25. If I go ahead and factor this left-hand side, I would end up with x minus 1 quantity squared. Then I could take the square root on both sides of my equation, and I would get x minus 1 is equal to plus or minus, the square root of 25 is 5. I can add 1 to both sides of my equation, and I would get x is equal to 1 plus or minus 5. Or x is equal to 1 minus 5, which would be negative 4, or 1 plus 5, which would be 6. So x would be equal to negative 4 or 6. All right, so you might notice immediately that number 6 and number 8, they look different than the other ones do, and that's because there's already a C sitting there. Well, when we're completing the square, we actually need to get rid of this. We need to move that over there so that we create our own value for C. All right, so I would have x squared minus 18x plus, I don't know, we're going to add in c, and then a negative 50 on that side. What I did was I just used the subtraction property of equality to move that 50 to the other side of the equation. Okay? So next I'm going to use half of b and I'm going to square it. Well, half of b would be 18, so I'm going to add in 9 squared here. And anything I add to one side of the equation, I got to add it to the other. 9 squared is equal to 81. All right? So 81 minus 50, that's going to be 31 over there. Okay? So I'm gonna factor this side here. So I'm gonna end up with x minus 9 quantity squared. And a little trick you guys might start to realize is it's always going to be that variable, that sign, and that number. It's one of the reasons why I choose to write it the way that I do. Okay, so after I take the square root on both sides, I'm going to end up with x minus 9 is equal to plus or minus the square root of 31. Guys, I can't really reduce this radicand. The radicand is this junk inside of the radical. I can't find a perfect square that's in that, so I'm just going to leave that in its exact form. I'm going to add 9 on both sides of the equation, and x is going to be equal to 9 plus or minus the square root of 31. If you want, you can get your calculator out and come up with some crazy old decimal that's going to end up being. I'm not messing with that. Okay? All right. Number 7. X squared plus 9x plus some square is equal to 3 plus some square. I think I can give myself some more space too. Okay? So I'm going to take half of b and square it. Well, in this case, I'm just going to leave it as a fraction. Okay? And over here, I'm going to go ahead and give you that fraction, which would be 81 over 4. Okay, I square the numerator, I square the denominator. All right? So when I factor this left-hand side, I would end up with x plus 9 halves, quantity squared, is equal to, over here I need to create a common denominator. 3 is equal to, let's see, 12 over 4. If I divide 12 by 4, I get 3. So it's 12 fourths plus 81 fourths over there. All right, so let's just go ahead and simplify that left-hand side. I'm going to copy this I'm going to simplify the right-hand side. Sorry, I'm copying the left-hand side. All right, I would have, let's see, that would be 93 fourths over there. All right, so the next thing I'm going to do is I'm going to go ahead and take the square root on both sides of my equation. All right, so I'm going to have x plus 9 halves over here is equal to plus or minus the square root of 93 halves. Okay, I went ahead and took the square root of the denominator. Not sure if there's anything I can do with that numerator. In fact, I want you to pause the video. I'm questioning that, so I'm going to pause the video just for a second to check on if I can simplify the square root of 93. All right, can't really do much with the square root of 93, so I'm just going to leave that. Here's what I'm going to do next. I'm going to subtract 9 halves on both sides of my equation using the subtraction property of equality. Okay, I'm going to end up with x is equal to 9 plus or minus the square root of 93. All over 2. All right, on number 8, again, kind of like number 6, you might notice, hey, we've got a c sitting here that isn't really going to work out as far as being a perfect square. So you might see your trinomial look like this quite a bit. So I'm just going to take that value and I'm going to move it over there. So I'll have x squared minus 6x plus, I'm going to put my own c in because I'm going to complete the square, is equal to negative 16. Okay? When I do that, I use half of b and I square it. So half of b is 3, and I'm going to square that. Anything I do to one side of the equation, I've got to do it to the other. So over here, I'm not going to add 9 squared over there. I'm going to add 9 over there. Okay? So on this left-hand side, after I factor it, I would have x minus 3 quantity squared is equal to, all right, we're going to have negative 7 over there. Okay? After I take the square root on both sides, we don't know in Algebra 1, you haven't learned how to deal with your imaginary friends yet. Okay? And when you get to Algebra 2, you can start to deal with your imaginary friends. But until then, you need to write that this has no, and I want you to use the word real solution, because there are some imaginary solutions. All right, it says use Desmos to estimate the values for which f of x is equal to 3. Then use completing the square to confirm these results algebraically. So let's head over to Desmos. All right, so I typed in 2 functions into Desmos. I typed in my quadratic that they gave me, x squared minus 6x minus 5. And then I typed in y is equal to 3. F of x is equal to y. So I just substituted y. And that's basically a horizontal line. Now, if you take a look, you can touch, if you're using your cell phone, you can touch the places where these 2 lines intersect. Okay, so the 2 lines that we are looking for, or the 2 points that we are looking for, are the 2 places where the line y equals 3 and the line or the graph of the parabola x squared minus 6x minus 5 actually intersect. All right, so we should get x is equal to negative 1.123, and we should get 7.123. All right, so let's confirm what we saw on Desmos algebraically. So let's substitute 3 in for f of x. So 3 is equal to x squared minus 6x minus 5. And I'm going to use this technique, completing the square. So I'm going to add 5 to both sides of my equation. All right, and now I'm going to use completing the square. I'm going to add whatever I want to both sides using the addition property of equality. What I want is half of b quantity squared. So I'm going to add in 3 squared, or 9. This side ends up as 17. If I factor this side of my equation, I would get x minus 3 quantity squared. Then I can take the square root on both sides, and I would get plus or minus the square root of 17 is equal to x minus 3. And if I use the addition property of equality, I would get 3 plus or minus the square root of 17 is equal to x. And if I take 17, using my calculator here, I'm using Desmos, if I take the square root of 17, I would get 4.123. So 3 plus or minus approximately 4.123, and I'm rounding there, is equal to x. Or x is equal to negative 1.123 and 7.123. All right, folks, that concludes your video on completing the square. Remember, in this unit, when it tells you that you have to use a particular technique, you must use that technique. If you use a different technique, you're not getting any points for that problem, even if it's correct.